Welcome. Today's lesson 2.1, the rectangular coordinate system and graphs. Let's start with the first learning objective. Plot ordered pairs in a Cartesian coordinate system. Okay, the Cartesian coordinate system, also called the rectangular coordinate system, is based on a two-dimensional plane consisting of the x-axis and the y-axis. Perpendicular to each other, the axes divide the plane into four sections, which we call quadrants. Okay, the quadrants are numbered counterclockwise as shown in figure 2. So basically it's just your x-y axis. So you got the x-axis, the y-axis, and then the origin is where they meet. And then you got, it splits the plane into four pieces. Quadrant 1, 2, 3, 4. And it's common that we use Roman numerals to label these. Okay, so the Cartesian coordinate system is a two-dimensional plane where the x-axis is the horizontal axis. The y-axis is the vertical axis. A point in the plane is defined as an ordered pair, xy, such that x is determined by its horizontal distance from the origin, and y is determined by the vertical distance of the origin. Okay, so let's try plotting these 3 points. All right, we'll start with the first one. So typically the way I do it, there's a couple ways people do this. One, you can say, all right, so -2, 4. So we got -2, 4. The 2 is your x coordinate. The -2, sorry, is the x coordinate, and the 4 is the y coordinate. So we're going to, from the origin, we're going to move 2 units to the left, -2 units, and then 4 units up. Okay, so we're counting from the origin. 1, 2 to the left, 1, 2, 3, 4 up. And then that'll be our point, -2, 4. All right, moving on to 3, 3. So start at the origin, 3 units to the right, 3 units up. And then the other way I could do it is basically for -2, 4, you can just go to the -2 on the x-axis and the 4 on the y-axis. And where those two grid lines meet, that would be the point -2, 4. So either method's fine. Okay, 0. So go 0, don't move, and then down 3. Okay. So then we got, this was 3, 3. 0, -3. Okay, on to the next objective, graph equations by plotting points. Okay, so graphing equations by plotting points. We can plot a set of points to represent an equation. When such an equation contains both an x variable and a y variable, it is called an equation in two variables. Its graph is called a graph in two variables. Any graph on a two-dimensional plane is a graph in two variables. Okay, so the key is two variables. I would also like to point out that when you're graphing, you're actually graphing the solution set of the equation. All the set of all numbers that make the statement true. So given an equation, graph by plotting points. So we're going to make a table. Basically, you're just going to make an XY table. And you're going to pick numbers for X. Oh, third column lists in the results of the ordered pair. Oh, they want you to do 3. All right, so basically you're going to put your equation and then your result. Okay, so you're going to pick a number for X. You're going to plug it into the equation, work it out, and then the result would be your Y. Select X and Y values that yield Y values with little effort, preferably ones that be calculated mentally. Then you're going to plot the ordered pairs and then connect the dots to form a line. So pretty straightforward. Okay, so let's try one. Okay, we're going to make our table. We're going to put X in the first column. Second column is going to have the equation. And then the last column would be your y. So we're just going to pick numbers and plug them into the equation to figure out y. So let's always start with 0. So y equals negative 0 plus 2, which is just 2. And then let's pick 2. Y equals negative 2 plus 2, which is 0. Now there's no rhyme or reason for what number. You just pick numbers, plug them in, pick numbers that work easy. So don't make them too big. Do some positives, some negatives. Let's do 2 more. So let's do 3. So y equals negative 3 plus 2, which is negative 1. And let's do a negative 1. How about negative 1? So y equals the opposite of negative 1. You know what? I should have minus a minus 1 plus 2. So this would be plus 1 plus 2, which would be 3. Now we're going to plot these ordered pairs. So 0, 2. You count from the origin. 0, 2. 2, 0. So we go right 2, up 0. Now technically you only need 2 points for the line. So that's enough. We can draw the line through it. But we like to do a couple extra just to make sure we didn't make any silly mistakes. So 3, negative 1. You can see how they're lining up now. So that gives me confidence that I didn't make any mistakes. Negative 1, 3. And then I can draw the line through it. Normally, if I'm doing it on paper, just get a straight edge, line it up on the line, and draw the line through it. And that's your line. Y equals negative 2x. Or negative x plus 2, sorry. Okay, next learning objective, graph equations with a graphing utility. So you can use a graphing calculator. Now, mind you, when you take the midterm and the final, you cannot use a graphing calculator. So you would not have this option for the test. So make sure you can do it by hand. But it's an important skill to know how to do it using some kind of technology. And I'm going to show you using Desmos. Okay, so this is a free utility. Just go to desmos.com on the internet. They also have an app that you can load on a phone. And it's pretty simple. You just type it in exactly the way it reads. So y equals negative 2/3 x. You got to make sure to, for the x to be on the top, not on the bottom. That plus 4/3. And the way I do 4/3, just use the slash or divided symbol on your keyboard. And that's it. Oh, that should have been a 3. And what's nice about this program, you can see where it that's what we call the y-intercept, the x-intercept. And you just click on it and it'll tell you the ordered pairs for that point. Okay, so you just kind of run your cursor along the line and it'll tell you what the ordered pair is at that point. Okay, so really nice utility there. Very user-friendly. It's, really recommend using this one. Okay, on to the next learning objective, finding the x and y intercepts. I just mentioned that on the graph, so I'll show you how to find it algebraically. Okay, so finding the x-intercepts and the y-intercepts. The intercepts of a graph are points at which the graph crosses the axis. Okay, the x-intercept is the point at which the graph crosses the x-axis. At this point, the y-coordinate is 0. the y-intercept is the point at which the graph crosses the y-axis, and at this point the x-coordinate is 0. All right, so if you can think of it this way, if we have the x and y-axis, and if you cross the y-axis, this point's going to be some number. It's going to be 0, some number. So I like to write it. Think of the y-intercept is 0b, and then the x-intercept is going to be some number for x, 0 for y. So if you know that, when you want to find the x-intercept, so here's the x-intercept, some number 0. You let y equal 0 and solve it for x. And then you switch it. For the y-intercept, you're going to let the x equal 0 and figure out what the y-coordinate is. All right, so let's look at example 4. If I want to find the x-intercept, okay, so for the x-intercept, so remember it's going to be some number 0, so we're going to let y, we're going to let y equal 0 and solve for x. Okay, so we're going to plug in 0 for y. And then solve it, so add 4. So we get 4 equals negative 3x. And then we're going to divide by negative 3. So x equals negative 4/3. Now we're going to do the same for the y-intercept. Okay, so for the y-intercept, so remember it's 0 for the x, and then we got to figure out the y. So we're going to let x equal 0 and solve for y. So we're going to plug in 0 for the x. So negative 3 times 0 is 0, minus 4 is minus 4. So y is negative 4. Now remember, when we plot this, it's the point. For the x-intercept, it's negative 4/3, 0. And for the y-intercept, it's 0, negative 4. Okay, so for the x-intercept, negative 4/3, so that's 1 1/3. If you make it a decimal, negative 1.33. So just imagine, I like the thirds, right? So that's like thirds, so negative 1 1/3. And then the y-intercept would be 0, negative 4. And then you get your ruler or straight edge, put it through those two dots. There's your line using the x and y intercept. So that's a great method for graphing as well. Okay, on to the next learning objective. Use the distance formula. So using the distance formula. The distance formula is derived from the Pythagorean theorem, right? So basically, if you know the Pythagorean theorems, a squared plus b squared equals c squared, where a and b are the lengths of the legs adjacent to the right angle, and c is the hypotenuse. So you can see that if this is a and this is b, the distance of a, you're going to subtract the x coordinates. So for this case, 5 minus 1 would be 4. Okay, and then this distance is going to be 6 minus 1. 6 minus 1, which is 5. And then you're going to do the a squared plus b squared equals c squared. So we end up with Okay, I'm not going to do the numbers, but just to show you the formula. So the A is you're going to subtract the x coordinates, and then you don't need the absolute value because you're going to square it. So you do x sub 2 minus x sub 1 squared, and then the y coordinates, y sub 2 minus y sub 1, and then square it. That's going to get you c squared, which we're going to call distance. And then to solve it for d, you square root both sides. Oops. This tablet doesn't work great for me. Okay, and then the square root cancel. And it'd be plus or minus technically, but we know distance is going to be a positive number. And there we have the formula. Okay, so we're going to subtract the y coordinates, the x coordinates, square it, subtract the y coordinates, square it, add those two numbers together, and then square root it. And that's the distance formula. Looking at example 5, find the distance between the 2 points, -3, 1, -1, and 2, 3. So to find the distance, we simply plug it into the distance formula. We're going to, now the subscripts, if I call this point 1, this is x sub 1, y sub 1. The subscripts are what we call distinguishing characters. So to tell the difference, these are both x coordinates, but this is the x coordinate from point 1. This is the x coordinate for point 2. So there's no math operation attached to that subscript. So we're going to subtract the x coordinates. 2 minus a minus 3. Oops. 2 minus a minus 3 squared. Subtract the y coordinates. 3. Well, this should have been y sub 2. 3 minus a minus 1. Now the order really doesn't matter since we're squaring it, right? If you switch the order, it changes the sign, but then when you square it, it makes it positive. So 2 minus a minus 3 is 5. 5 squared is 25. 3 minus a minus 1 is 4. So we get 25 plus 16. So D equals, what's that, 41? And that's our answer. If you punch it in a calculator, you can get approximately, so approximately 6.403, right? Math, we like exact numbers, so square root of 41 would be the answer. But if we wanted to, have some meaning to that, it's about 6.403. Okay, and to the last learning objective, use the midpoint formula. Alright, so using the midpoint formula, when the endpoints of a line segment are known, we can find the point midway between them. This point is known as the midpoint, and the formula is known as the midpoint formula. Given the endpoints of the line segment, so again, the subscripts to distinguish between the 2 points. So you got an x and a y coordinate. This is the x coordinate for point 1, y coordinate for point 2, x coordinate for point 2, y coordinate for point 2. Did I say y2? So this is point 1, so x1, y1. This is point 2, x2, y2. All right. So the midpoint formula, basically I think of it as an average, right? How do you find the average between two numbers? Well, you add them and divide by 2. So to find halfway in between, you average the 2 x coordinates. You add them, divide by 2. To find the halfway in between, it's the same thing as saying what's the average. So you add them, divide by 2. That's just the way I remember it. Okay, so looking at example 7, find the midpoint between the line segment 7, -2, and 9, 5. Okay, so we just plug it into the midpoint formula above. So we add the x coordinates, add the y coordinates, divide by 2 for both. So let's see, the x coordinates 7 plus 9, y coordinates -2 plus 5. So m equals, so 16 divided by 2 is 8, and 3 divided by 2 is just 3/2 or 1.5, and that's our midpoint. Example 8, find the center of a circle. The diameter of a circle has endpoints -1, -4, and 5, -4. Find the center of the circle. So basically what we're doing here, let me just draw you real quick. Okay, this is not scale, I don't have it on axis, but a diameter, if you don't know, the diameter is a line segment or a chord of the circle that specifically goes through the center of the circle. Oops. I don't know what happened there. So anyway, so if I were to say that's, so, and then the midpoint would be where the center is, right? So we're going to find the midpoint, and again, this is not to scale, so -1, -4, 5, -4. Okay, so the center, the midpoint, would be, we're going to add the x coordinates. Divide by 2, add the y coordinates, divide by 2, and that'll get us our center. So let's see, I'm going to add the x coordinates. So I didn't have to draw the picture, and again, it's not done right because you can see this is probably a vertical line. So we'll go -1 plus 5 divided by 2, and -4 plus -4 divided by 2. So that'll be 4 divided by 2, which is 2. -8 divided by 2 is -4. So the center is at the center is at 2, -4. All right, and that brings us to the end of this lesson. So make sure to practice exercises at the end of this section, and I'll see you next time.